The purpose of a steep spiral is to aid the pilot in understanding performance factors associated with steep spirals while maintaining the airplane's position in relation to a point on the surface. Steep spirals teach the pilot how to maximize the performance from his or her aircraft while using control accuracy to remain over the selected point and roll out at the specified altitude after 3 turns over that point. During setup, select an entry altitude that will allow for completion of 3 360-degree turns with the recovery to be completed no lower than the minimum recovery altitude of 1,000 feet AGL. Dual flights may perform a simulated emergency landing at a suitable airport. After entry altitude has been established, clear the area by performing 2 90-degree clearing turns. For setup, satisfy the B-GUMP acronym by turning the boost pump on, switching gas to the fullest tank, verifying undercarriage up, selecting mixture rich, and by moving the propeller to high RPM. Finally, select a suitable ground reference point. An intersection will work great for a point due to the fact that it is very easy to judge your reference using the extending roads when at high altitudes. The technique used for steep spirals can be compared to that when practicing turns around a point. Consider that during the maneuver, the pilot should maintain an equal radius of turn, preferably a quarter mile in radius, from the pre-selected point on the ground. To accomplish this, the pilot should make bank angle corrections when flying between a headwind and a tailwind. During steep spirals, the pilot must also divide his or her attention to maintain a pitch attitude between these varying bank angles that will allow for a stabilized descent airspeed. In the Aero, UND standardizes this airspeed at 95 knots. The maneuver should be entered by first reducing power to idle as the aircraft is transitioned to 95 knots. A gliding spiral should be started and a turn of constant radius maintained around the selected point on the ground. As the pilot enters a tailwind, bank should be increased to maintain a constant radius. Conversely, bank should be decreased when tracking into a headwind. In contrast to turns around a point, the pilot must vary pitch attitude to maintain a constant airspeed throughout the entire maneuver. As bank is increased, pitch must be brought forward to maintain airspeed, but as bank is decreased, pitch must be brought back smoothly to maintain that same airspeed. The pilot should continue these smooth control inputs for the rest of the maneuver in order to accomplish 3 complete turns. Keep in mind, unlike turns around a point, as the aircraft descends vertically, wind direction may and usually does change. Therefore, the pilot will have to constantly adjust control inputs to compensate for changing wind conditions. Also, the pilot should perform what is known as clearing the engine, where at the completion of each turn, power is brought forward smoothly and then reduced back to idle in order to avoid fouling the engine's spark plugs and to aid in creating residual heat for the engine during cold weather operations. Finally, as the third turn is being completed, the pilot can roll out on a pre-selected heading which would simulate a pattern entry to a point on the ground where a forced landing could be made. If on a dual flight, the student may perform a gliding turn to an airport where a power-off landing can be made. Remember, a spiraling descent over an airport must be completed while making applicable airport radio calls in order to ensure traffic separation. It is the pilot's responsibility to see and avoid all traffic during the entire spiraling descent by dividing attention in and out of the cockpit. The commercial PTS requires that the pilot select an entry altitude sufficient to continue through a series of at least 3 360-degree turns. The pilot must select a suitable reference point and apply wind drift correction to maintain a constant radius with a bank not to exceed 60 degrees at the steepest point of the turn. Finally, the pilot must maintain airspeed plus or minus 10 knots and rolls out toward a specified heading within plus or minus 10 degrees. For further information on steep spirals, reference the Airplane Flying Handbook, Chapter 9, and the UND Aero Standardization Manual, Chapter 3. Have fun and fly safe.